This is part 10 of the Module 11 lecture. In this part, we're going to talk about the confidence intervals for predictions made with the regression model. And this corresponds to section 13.6 in your textbook. All right, so prediction confidence intervals, when you make a prediction, there are two possible intervals that you can construct. And again, every point estimate must be accompanied by a confidence interval. In regression analysis, we accompany those predictions by two confidence intervals. The first one is a confidence interval about the mean of the response. So this mu y for a particular value x sub 0, and what we call a prediction interval for a single predicted value, this yp for x0. So you could be predicting for the average, or you could be predicted for a single value. And we distinguish the two confidence intervals by calling the confidence interval. When we say the confidence interval, we refer to the confidence interval for the mean. When we say the prediction interval, then we refer to the confidence interval for a single predicted value. If we go back to our example where we were talking about GPA and hours worked per week, if you remember, this is the regression model that we estimated using least squares. And so we started this problem with a student interested in seeing how his GPA will be affected if he went from working only 8 hours per week to 16 hours per week. So now using this model, we can predict how the GPA will be impacted by someone that works 16 hours per week. And we see that this is 2.8588, which you can see graphically here, where we have the sample regression model, and we're making a prediction for 16 hours worked per week. And we see that the value of the GPA is 2.8588. Now the question, what is this? So this actually has two possible meanings. Previously, we just referred to it as the meaning that it represents the average GPA for all students that work 16 hours. But it also represents the point estimate of the GPA for a single student selected at random. So this thing could be interpreted two ways. But whichever interpretation you give to it, you must accompany it by the correct confidence interval. All right, so to calculate the confidence and prediction intervals, you need to justify the use of the t-distribution. And in regression analysis, we remember that the assumptions of regression analysis is that for any value of x, the random errors are independent, normally distributed with a mean 0 and a constant standard deviation. And the standard deviation is estimated with the standard deviation of the residuals. This last step, so the fact that the errors are normally distributed, and the fact that we're estimating the population standard deviation of the errors with the standard deviation of the residuals, then that justifies the use of a t-distribution, but with n-2 degrees of freedom. And this same distribution will be used to calculate the confidence interval for the mean and the prediction interval for a single value. All right, so keep that in mind. So every time you use a confidence interval, you need to justify what distribution is being used to construct that confidence interval. All right, with that in mind, then let's talk about the confidence interval for the mean for a particular value of x0. So in other words, we're making a prediction about this parameter. And the best estimate value is the one that we predicted with the sample regression model. And so now we construct the lower of the confidence interval. So here's the lower limit. So this is a value predicted from the sample regression model. This is a critical value from table 5. using alpha divided by 2 and the degrees of freedom. This is the standard error of the residuals that we already calculated. And this is the inverse of the sample size. And this is the variability depending on how far the value that we want to estimate is from the mean of the x values. And you notice that when the value that at which we want to make a prediction is equal to the mean of the x values, that whole term disappears. So that's the lower level of variability that we will have. But as you move away from the average of x, then this difference increases. That means that the variability, because you're getting farther away from the center point, then it increases. So that's what this term accounts for. And the upper confidence interval limit is just like this, but we add this whole term. All right, so how do we interpret this confidence interval? So once you calculate this, the interpretation of this confidence interval is that the population mean of the response for the value x0 is between these two limits with a confidence level of 1 minus alpha times 100%. So we'll see how we interpret this in practice, but this is the general interpretation of the confidence interval for the mean. All right, so the prediction interval for a single value that we're designating as y sub p, phi predicted, then the confidence interval is constructed identically to the previous confidence interval. So we have the value predicted from the sample regression model. We have the T alpha over 2 obtained from table 5, the standard error of the residuals. And now we have this new term 1. And that means because now there is the variability associated with a single value. So the deviation from the single value from the mean. So we're really estimating it with the t value and the standard error, plus that 1 over n, and taking into account how far we are from the mean. So this confidence interval has a new term here. And the upper confidence interval limit the form is identical, except that here we add this whole term. And because this new term, the one in here, of course you can see that this confidence interval will be wider. And that makes sense, because when you're predicting a single value, there is more uncertainty. Because it's not only the uncertainty of estimating the mean with a sample model, but also the uncertainty of the deviation of the single value from its mean. All right, how do we interpret this confidence interval? Well, we said that the response value y of a random element in the population for a value x sub 0 is between these two limits with this confidence level. All right, so again, we will see, this is the general interpretation. We'll see how we interpret this in an actual example. And as I said, remember that this prediction interval is wider than the confidence interval. All right, let's look at an example. So this is the example that we've been working with. And again, we're interested in predicting what happens to the GPA when the student changes from working from 8 hours to 16 hours. So we're going to calculate both the confidence interval for the mean of the GPA for all students that work 16 hours and the prediction confidence, the prediction interval for the GPA for a student selected at random that works 16 hours per week. All right, so using the regression model that we already determined, so we have these quantities that we already calculated, the mean, the sum of squares for the x squares, and the standard error of the residuals. And here is the prediction based on the model for 16 hours worked per week. So we see that the GPA is 2.8588. All right, with that information, then we can compute the confidence interval. So first we need to go to the table 5 using alpha over 2 and the degrees of freedom to find the critical value, 2.306. All right, so here this y hat x sub 0 is the value predicted from the model. Then this is the critical value we found in table 5. This is the standard deviation of the residuals. There are 10 observations, and the mean of the x is 18.3, or the x values. And this is the sum squared of the x squares. So again, putting all these numbers together, you see that the lower confidence interval limit is 2.5328, and the upper limit is 2.1848.
So in this case, we say that the mean GPA for all students working 16 hours per week is between 2.5328 and 3.1848 with a 95% confidence level. So all students working 16 hours per week would expect the GPA to fall between these two limits. All right, so now to calculate the prediction interval, again, we use the information that we know, but now we have this formula with this 1 here. So we plug in all the values. And remember, this 2.859 is the value predicted from the sample regression model. And now we find that the limits are 1.7702 and 3.9474. And remember, be careful with these calculations because now they're getting a little more complex. And the worst thing is Excel does not calculate these things automatically. So you will have to put these formulas in Excel if you want Excel to calculate these quantities. All right, how do we interpret this confidence interval? So we say that, or rather this prediction interval. So we say the GPA of a student selected at random from all the students working 16 hours per week would be between 1.7702 and 3.9474 with a 95% confidence level. And you can see that this confidence interval is wider because there is more uncertainty about predicting the GPA of a single student. But now that student can use this information and decide whether or not he or she wants to work more hours per week. All right, so these are the confidence interval and their interpretation. So in the next recording, we'll talk about verifying the assumptions of the regression analysis.